welcome back to our virtual classroom. So this is our second math lesson today, and it's going to focus on equivalent fractions. We've done that before. It shouldn't be new to any of you. You should remember what we've done in class, but I want to review it because it's going to be coming up in our future lessons on this channel. So you're going to need to have a firm grip on how to find equivalent fractions and how to tell if two fractions are equivalent. So make sure you have a pencil and your notebook, and let's get started.
All right, so here is the date, topic, and learning intention for you to copy into your book. I'm doing this on blank paper because I noticed in the last video it was a little bit blurry when I uploaded it, so I'm hoping that having the writing on white paper will make it easier for you to see. But please continue writing on your lined paper because as you can see mine is a little wonky. Again, our topic is equivalent fractions. Our learning intentions: find equivalent fractions, which you should already be able to do. And we're going to be looking at determining if two fractions are equivalent. So we'll look at two fractions and say, are they the same? Do they have the same value or not? All right, so we're going to start with a simple fraction, a half, and we're going to find something that's equivalent to it. What I've done, I got a piece of paper, yellow paper, and I split it in half right down the middle, as you can see. And half of the paper is green, the other half is yellow. One out of the two pieces is green. One out of the two pieces is yellow. Now I can find a fraction that's equivalent to a half by folding this paper again or drawing another line down it. So you might see that I have a faint line going across the middle. I'm just going to trace that. Now, has this really changed? Half of my paper is still green, even though I now have two sections that are green, and half my paper is still yellow. If I ignore that line, I can still see that half is green and half is yellow. But now I have a new fraction. 2 pieces out of 4 are green. 2 over 4. Now I know that this is equivalent to a half because 2 is half of 4. Something we've been doing in class is multiplying the numerator and the denominator by the same number to find equivalent fractions. What did I have to multiply these two by to get to 2 over 4? Well, 2. 1 times 2 is 2. 2 times 2 is 4. That's a nice, easy example of an equivalent fraction. But what if I didn't have a piece of paper to work with, and I needed to find an equivalent fraction that was much larger? Well, I can still use the same strategy. I can multiply by the same number on the top and the bottom to find an equivalent fraction. Let's multiply by, I don't know, 12. And we're going to do the same to the bottom, multiply it by 12. So 2 times 12 is 24. 4 times 12 is 48. How do I know, though, that this is still equal to a half? Well, I can check. Is 24 half of 48? If I double 24, I should get 48 exactly. So let me check off to the side. Hopefully you've done this in your head already because this is a nice simple addition problem. 4 plus 4 is 8. 2 plus 2 is 4. There's my 48. So I know that 24 must be half of 48. So it's still equal to a half and it's equal to 2 quarters. All right, so now that we've done a review of how to find equivalent fractions, let's see if we can determine if two fractions are equivalent. We just recapped that for two fractions to be equivalent, you have to be able to multiply the numerator and the denominator by the same thing and get to the other fraction. So let's check if I can multiply 4 by the same number as 7 to get to 8 and 14. Well, I see that to get from 4 to 8, I have to multiply by 2. So for this fraction, 4/7, to be equal to 8 over 14, I have to be able to do the same thing to the bottom. Is 7 times 2 14? Yes, it is. I can do the same thing to the top and the bottom. That means these two fractions are equal. Now, what about over here? 6/12 and 30/48. Well, let me see how I can get from the top number, 6, to the other top number, 30, the numerators. To get from 6 to 30, I have to multiply by 5. 6 times 5 equals 30. Can I multiply 12 by 5 and get to 48? Well, let's see. 12 times 5. I know from my times tables that 12 times 5 is 60. For me to get to 12, from 12 to 48, I would have to multiply by 4. I have not done the same thing to the top and the bottom. They're different. That tells me that these two fractions are not equivalent. So, no, they are not equivalent. When you put a slash through an equal signs, that means that they're not equal. They're not the same. So here I have equal, here I have not equal, because these numbers are not the same. Let's try another one. 5/8 and 12/40. Well, right away I'm looking at 5 to 12. I can't think of a single way to get that done. Well, let me try to get from 8 to 40. 8 times 5 gives me 40. That must mean that if I multiply the bottom by 5, I should be able to do the same thing to the top. But 5 times 5 is not 12. So I'm going to put a question mark up there. How do I get from 5 to 12? That tells me that these two fractions are not equal. I'm not doing the same thing to the top and the bottom. For these to be equal, it would have had to be 5 times 5, which is 25 over 40, not 12 over 40. So I can put a not equal sign. Let's try one more. 11 twelfths and 66 70-seconds. I think that's how you say it. Well, to get from 11 to 66, what do I have to do? I have to multiply by 6. 11 times 6 gives me 66. If these two fractions are going to be equivalent, that means I should be able to multiply 12 by 6 and get to my denominator over here. Is that true? 12 times 6 is in fact 72. Oh my goodness. 12 times 6 is 72. So that means since I did the same thing to the numerator and the denominator, these two fractions are equal. So here is your independent work. Question 1. Find 3 equivalent fractions for each fraction below. A, 6/9, B, 4/10, C, 8/11, D, 7/12, E, 3/8, and F, which is the bonus, 37/50. Please write this neatly in your book and you'll take a picture and send it to me. Question 2. Are these pairs equivalent? Show your work and use the equal or not equal signs. For each of these, I want you to draw the arrows to show how you get from one numerator to the other and one denominator to the other. You need to keep in mind that if they are equivalent, it should be the same thing that you've done to the top as the bottom. Again, take a picture of this and send it to me when you're done. All right, you guys, stay safe and see you soon.